Hello, my name is Diego Moreno, and these are my teammates Mauricio Lastres and Sebastian Lopez, and we are presenting the design of robots in grinding and polishing. Grinding is a process that's used to finish surfaces and actually to mold and to form different products. And what it does is it's an abrasive disc that removes usually metallic products from the surface. The polishing process, this is a machine that does polishing and grinding. And what it does is that it smooths the surfaces to get different applications. Usually, they are usually also done just to get a nicer surface, maybe well, what you call it, bright and shiny surface.
As we all know, the manufacturing process is very involved, and in many cases requires many stages to actually come from the beginning of a product all the way to a final product that's actually used perhaps as a consumer product for sale. So typically what happens is, like in the case of a casted product, the surface roughness is excessive, and then there will be multiple stages that will take the product from its original casted form to a final product. And in this situation is where the grinding robots and polishing robots are used. In some cases you can have multiple robots for each stage, or you can have one robot that could have multiple tooling capabilities that could actually do all these steps. But it's very important to go from the casted product all the way to a grinded product through grinding and polishing, which will take you all the way to a final product that can be used for sale. Now, traditionally, these tasks of grinding and polishing were left to be done manually by humans, and grinding and polishing robots have actually alleviated, taken away the necessity of doing these tasks manually. Industrial robots have become very important in the manufacturing process because not only do they free human beings from having to do these tasks, but actually they've also improved the quality of the products and the precision of which they're made. So there's actually an improvement in the quality by using robots and automation.
Okay, this is a bell grinding process. We know a bell grinding is a machining process. We are geometric indeterminate cutting edge. So we can see here, this is the lasting grinding wheel. We have the grinding belt, and then we have the workpiece that is going to be done. Then right here we have a rotary robot. This is a 4 robots working. It's going to be a little easier. You know, sometimes we have one working. We have 4 right now, so it's going to be more work being done faster time. So dead time elimination, we know that the precision is maximized, improvement of the cycle time. We know there's going to be an automatic loading and automatic unloading, detection of the grinding bells finishing. Then right here we have another type of robot, or machine if you want to call it. Then this is a station for robot grinding and polishing combined with 2 robots. Warehouse parts automatic positioning. One robot is going to be loading, the other one is going to be grinding, then pass it to the other one that is going to be polishing. Then right here we have another application. This is a car polishing robot. It's polishing the side of the car.
Now, grinding and polishing is one stage of the manufacturing process, and it has been used more and more in the United States and modern countries because it drives down the cost of manufacturing. This is very important when you look in a global scope because of increased competition from countries that have low wage labor. And low wage labor is they're very competitive because of this, and countries like ours cannot compete with those countries using human or manpower. So it's very important to increase automation so that it makes manufacturing here in the United States more competitive with those countries. It's important to point out that human beings are taken out of the grinding and polishing, actually improves the quality of the products and increases the efficiency of the manufacturing process, again making the manufacturing here in the United States more competitive by using automation.
Okay, so the conceptual design, the proposed design is an RPR robot. We know it's 3 degrees of freedom. The design robot is capable of polishing and grinding both curves and flat surfaces. An application we use propane tank grinding and polishing.
Okay, so the concept schematic here, we can see that we have a 3-arm robot, a very long arm, 2 meters to 100 centimeters. Here we have a prismatic joints in the first angle called S2, and the third angle we have the third arm, which is 50 centimeters long. The prismatic joint can go from 40 to 90 centimeters long. This is the first task model in the SolidWorks. The first arm is actually fixed, and the second arm is a prismatic joint which moves and extends while the end effector polishes the top surface of the propane tank. The second task model here is the same arm fixed. Now the end effector has a different angle, and to approach the side of the tank, it's a 90-degree angle to the tank, and also the prismatic joint extends to reach the lower surface of the side of the tank. This angle is kept constant, but the first angle on the revolute joint is moving along.
Okay, these are the graphs that were done in Excel. So we know that this is task number 1, task number 2, the joint positions. So we can see here that the end factor and the joint tool are going to have like the same shape, the same curve. Then we know that task number 2 were the ones that were polishing the side of the tank. So the angle is going to be the same. So right here we have again task number 1 and task number 2 joint angles. Then we know that this is going to be an angle times the time, and it's going to be a constant. We know that this one is not going to be angle number 1. We know that task number 2 joint is going to be constant. Then we know that angle number 1, there's going to be the arm that is going to be moving. It's not going to be constant.
These are the plots of the length of the prismatic joint, and in both cases, from its home position or neutral position, the prismatic joint extends itself, and it goes in both tasks almost to its full range. So at the beginning of the first task, as it sweeps across the dome, it'll go from almost 50 centimeters long to almost 80 centimeters long. And similarly for task number 2, as it sweeps along the sides of the tank, it'll go from around 55 centimeters to almost 90 centimeters, which is fully extended.
This is going to be a task number 1 animation. You see it's going up and down the tank. Then task number 2 is going to be how I explained to you. It's going to be going on the curves on the sides of the tank.
So as a conclusion, grinding and polishing robots are just keep growing in importance in the manufacturing process. We conceptualized a 3-degree of freedom robot which could grind and polish curved and flat surfaces, and 2 tasks for the robot were designed by using SolidWorks and analytical methods. Thank you very much.